about the efficacy and accuracy of postnet for posture detection. So, a deep learning approach in JavaScript using ML5.js framework. Postnet basically it is a computer vision model and it is used to detect real-time post detections in images. So, real-time analysis and monitoring of body positions. This is needed in variety of applications and in variety of sectors such as
I think she was having some connection issue, disconnected. So I think I can request the other participants. So if they are ready, they can present now. You can raise your hand if you are ready. So we can call your name for presentation.
All right. I think Dr. Indrajit is here. So maybe Dr. Indrajit can start with his presentation. I think the paper titled Forecasting Inflation Rate in Case of Uzbekistan Using Seasonal ARIMA Model. So Dr. Indrajit, maybe you can share your screen.
Welcome, Dr. Indrajit.
Yes, I'm sharing. Yes. So is it visible?
No, now it is visible. Yes.
Okay. So hello, I'm Dr. Indrajit Sinarai from Amity University in Tashkent. Okay,
Can you
so
put on full screen mode, please? Slideshow.
So I'm not sure of how I had to do the slideshow or.
I think you can go ahead, sir. It's okay.
Okay, fine.
Okay. Okay, so this is a paper we have jointly written. I have jointly written with Dr. Rajneesh Clay, and this is about evaluating forecasting inflation rate in case of Uzbekistan using a seasonal ARIMA model. The purpose of this paper is to forecast inflation accurately, and we have chosen the case. Uzbekistan is one of the leading economies in the Central Asia region, and it is a very dynamic economy. And if we can forecast inflation with much more accuracy, then it will give much more policy. It will give much more elbow room to the policymakers here, and also internationally, to predict perfectly about the forecasting in the economy and the concomitant policy options that follows from that. Okay, so here we have used a autoregressive integrated moving average model. That is the traditional workhorse model for the time series forecasting. And because we have there is a variation of this model called seasonal ARIMA model, So these two models we have worked here. Actually, it is a combination of two models that you are using the autoregressive integrated moving average model with seasonal data. Okay. So for doing this ARIMA model, first we need to check that whether the data is stationary or not. And this ARIMA model can only be applied to stationary data. So we first check that whether the data we have got, which is inflation data, we'll subject it to the first stationarity test and then apply the ARIMA model on it. So there is in the literature, like let's just just browse through some of the main points of the literature that about inflation forecasting. There are applications of ARIMA model and seasonal ARIMA model in the inflation forecasting before, and this is one of the most leading method to forecast inflation throughout the world. And we are using it for the case of Uzbekistan, and this is our contribution to the literature. So the ARIMA model basically of three components. They have three components. First, what is the order of the autoregression? That is how much it is dependent on itself. Okay, and integrated, this part means that how many times you need to difference it to make it stationary. And moving average means that how much the error behavior, okay, what is the order of the error behavior. Okay, so these three parts, if you combine, you get a ARIMA model of PDQ order. Okay. And now for the seasonal ARIMA model, we also need to add the term seasonality. That means how the pattern gets repeated over a season. And that season can be like a quarter, 6 months, or 12 months, depending on the data we face. So that one, and if you combine this seasonality with the ARIMA framework, then we get seasonal ARIMA model. So we have two types of data on inflation. One is month to month, which is monthly data basically. And this runs from 2016, January 2016 to October 2023. And this month to month inflation, this is the, when we graph it, this is the pattern. And for this data, we we derive the ACF, that is autocorrelation plot and partial autocorrelation plot. Okay, and if you see this plot, particularly the autocorrelation plot, you can clearly see that there are a pattern, and this pattern is that within a season, which we identify almost every 6 months, there are the values are very much correlated. Okay, and that's why this kind of different seasonal clusters you can see here. Similarly, in the partial autocorrelation function plot, that is PACA plot, we see similar patterns also. Okay, so this clearly indicates that there are seasonality in our data, and we have to take into account those things. Okay, and overall, these patterns are also indicative of ARIMA model of order 1, like the PQ term will be of 1 each. Okay, because the general pattern of the ACF and PACF plot is also telling that. And we can infer that there the seasonality is of the order is 6. Okay, so we will run that model on our data. We have another data on year-to-year inflation, and we'll also do the test regarding that, but that will be a simple ARIMA model, because that is a yearly data. We do not have the seasonal pattern there. Okay. So first of all, on our data, we run the Dickey-Fuller test, and the Dickey-Fuller test say that there is no need of differentiating the series because the series is already stationary. That is the message from Dickey-Fuller test. So the D term in our ARIMA model, we can say it is 0. From this Dickey-Fuller test, we got the result. Okay, and there we reported the main ARIMA model report, and basically we have based on that we have also forecasted the values of for next 5 periods, that next 5 months, based on the estimated model. And if you see the picture, we have both projected both the actual value and the forecasted value. The predicted or forecasted value in the red and the actual value in the blue, and see that how these two patterns are very much almost mixing with each other so well. Okay, that means it's a very good model to predict this data. And so because this in sample match is so much between the predicted value and the actual value, so we can trust this model to forecast out of sample periods. And we have done out of sample period forecast, and in one case we have used as a test case. Okay, for September 23 we have used as a test case, and there we got a very good prediction model, prediction which closely matches with the actual data we have. So that shows, that indicates that we have a very powerful model to predict the inflation rate in Uzbekistan using the seasonal ARIMA model. And remember, this is all MOM, that is month to month, like inflation. This is the monthly data we have done. Now we have a year-to-year inflation also, and this is the plot of it. And here, if we just see the plot, we do not see the extent of seasonality in a regular way. There is no clear pattern about seasonality. So that gives indication that is not a seasonal data, it is a yearly data, that is evident. And if we make the corresponding plot, ACF plot and PACF plot, that is autocorrelation plot and partial autocorrelation plot, we do not see the evidence of seasonality here. Okay, so, and this autocorrelation plot indicates it's a autoregressive of order 1. And the PACA plot also indicates that it is a, like, together it also, like, we can infer that it is a autoregressive process of order 1, and the moving average term is also of order 1. And again, and there we do the Dickey-Fuller test on it, and we found that it is non-stationary. Okay, so the year-to-year series is non-stationary. Thus, we need to difference it out once to make it stationary. And once it make it we take the first difference, we get a stationary series. So for this case, the ARIMA models, the integration term, that is, this ARIMA model will be integrated of order 1. So we run this model, this 101 model, that is, this is autoregressive of order 1, and moving average order is also 1, and the differencing order is also 1. Differencing order, we keep it 0 because we are dealing with already a difference data. Okay, so if we keep the original data, then we would have 1 1 1, but because we are doing with the difference data, so we kept the 0. And here we run this model and did the forecasting, and we see again that the in-sample forecast are matching with each other. In-sample forecast and the actual data is matching very much. And that gives credence to our model, that how the model is predicting the data. So we can use it for predicting the out-of-sample forecast. Out-of-sample means that which is out of the period, which period are yet to happen. And we have done so. And when we did for some September 23, this is a test case again, because we want to test the accuracy of our forecast, and we compared with the actual value of September 23, and we got fantastic match. So this gives further evidence that our model is a very good predictor of the actual process, actual inflation process in Uzbekistan. So what we develop throughout our combined research is that we have found a very good, credible model of forecasting for Uzbekistan's inflation rate, and the forecasting accuracy is quite high. And this model, we can use it for not only forecasting inflation, but this inflation rate, when forecasted, can contribute to other like very economic variables which are very important for the economic growth and development of Uzbekistan, like we can say of interest rate. Okay. And because inflation rate affects so many economic variables, so this is going to be a very important contribution as far as Uzbekistan is concerned. Okay. And in future, we will also extend this model, okay, to cover other economic variables for Uzbekistan, and that is our future task. So I completed the presentation now. So if any questions, please feel free to ask.
Thank you, Dr. Indrajit. It was a wonderful presentation.
Thank
No
you.
questions from my side. If Dr. Anish is having any questions, Professor Anish, please.
Yeah, thank you, Dr. Indrajit. It was a very concrete presentation, and I think I'll just add to it because I'm also one of the co-authors with Dr. Indrajit. The actual figures of October 2023, if you look at the actual inflation rates, we predicted the inflation rate for month on month to be approximately 0.66%, right? And the actual rate of inflation is 1%. Of October. And for year on year, the inflation rate that we predicted is 9.09, and the actual rate of inflation is 9%. And just to add to the knowledge of the participants, Uzbekistan's monetary policy regime is on inflation targeting as of now, and they are targeting inflation rate to be 5.1% in coming 6 months. But our forecast, can add to the policymakers that how they can target the inflation levels with this forecast. I think wonderful attempt, Dr. Najit. Thank you so much. I don't have any question as such.
Thank you, Dr. Rajnish, also to point out. And in this respect, we can maybe for this, we can add in our future work here regarding this paper, a confidence interval for this forecast, which will be putting in our main paper.
True, true, true. Okay, thank you. Now I would request Dr. Ramaya George, if you're ready with your presentation. Is that okay?
Good morning, doctors.
Good morning. Maybe Dr.
Actually,
Idris, you
I'm
can
sorry.
stop sharing your
Yes,
screen.
I'm.
Just click on stop share.
Stop. Okay. Yes.
That's it. Thank you so much.
Okay, welcome.
All right, Dr. Ramaya, please continue with your presentation. Thank you so much.
Good morning, doctor. Actually, I had some technical issues, and while presenting my presentation, like the Zoom link was closed. So I'll start the presentation now. This presentation, this research paper entitled Evaluating the Efficacy and Accuracy of PostNet for Posture Detection, a deep learning approach in JavaScript using ML5 framework. Basically, PostNet, it is a computer vision model which is used for detecting the postures within an image. So it can be used in real-time analysis, along with it can function in real time, along with different types of devices. The devices vary from smartphones to high-end computers and in various conditions, like from controlled environment to an open environment. So the accuracy, there would be like the findings found that there is a significant change in the level of accuracy attained with um, the range of the devices that we use and the environments. So basically here we use TensorFlow.js JavaScript and ML5 JavaScript. TensorFlow, it is developed by Google and it is a open source platform. and it simplifies the implementation of complex machine learning algorithms like postnets. So the factors that we are considering are the user interaction and the environments. These are the factors that we are considering: user interaction and experiences. So this research focusing on evaluating the computational demands and efficiency of PostNet, which is used to find the poses in real-time images, and it is based on browser-based environment. So it found the factors that we considered here are the real-time postures along with user interaction and experience. So the studies, it's sought to provide valuable insight and actionable recommendations for both developers and researchers. So in literature review, it was categorized under 5 categories based on the postnets in diverse applications, technical aspects of postnet, deep learning in web technologies, user experiences and interactions, postnet's accuracy and performance. So the literature review, it was conducted based on these 5 themes, and there would be some gaps. The research gaps were identified, and based on the research gaps, the experimental study is designed. So the methodology which followed here are implementing postnet using ML5 JavaScript. Based on that, the data is collected, experiments are designed, and evaluation criteria are defined. Based on that, the collected data is analyzed and the result is interpreted. So the device types that are used here are smartphones, tablets, desktop, laptop, high-end computers. And the postures considered are in sitting position, standing position, bending, walking, sports, etc. And we could find there is a level of change in the accuracy of the postures attained. Also, when you consider the environmental factors, controlled studio environment with high-end desktop, the accuracy is the highest. We attained 95% accuracy, and for laptop in office settings, 90% accuracy is obtained. And for tablets indoor, 85% in low light. Smartphones with outdoor bright light, 80%, and with variable background, 78%. So here there is a significant difference in the accuracy when it is conducted with high-end computers and in a controlled studio environment. The accuracy attained is 95%. And we could see that there is a low accuracy when we are using smartphones in outdoor and bright light and in variable background. So the experiment, it found like promising capabilities in posture detection, and it could found that the environmental factors and the computational power of the device, it affects the accuracy. It affects the accuracy in postnet. Thank you so much.
Thank you, Dr. Ramya. It was a fantastic presentation, I would say. Any questions from anybody?
I think no question from my side.
Okay.
Okay. Dr. Manik, if you are ready, or Dr. Tanveer.
All right. Thank you, Dr. Ramya. I think it was a fantastic effort, and all the best to you.
Thank you, doctors.
Manik sir is ready, I think. So we
I
can
would request
request
Dr.
Manik sir.
I think I would request Dr. Manik and Dr. Sanjay Mishra. Dr. Manik and Dr. Sanjay Mishra.
I request Dr. Rajneesh, if you can just request participants to open the camera so that you can take one screenshot
Yes,
as a
yes,
memory of this conference.
yes. Can everybody please open up your cameras, please?
And you can take one screenshot for the attendance.
Dr. Tanveer, can you open up your camera, please?
I'm here.
All right, that's perfect. Dr. Nazia?
It's okay. I think we can take a
Okay,
screenshot.
I've
Then we can
taken a
proceed.
screenshot. I've taken a screenshot.
Okay. Thank you, Dr. Rajneesh.
Okay, so I would now request Dr. Manik and Dr. Sanjay Mishra to continue with their next presentation.
Sir, is it visible to everyone?
Yes, it is visible, but can you put it on full screen mode, sir? It will be much better.
Good morning, everyone. The topic of my presentation is, does domestic tourism derive inflation rate or inflation restrict the domestic tourism? So that was the study that we were trying to do. My co-authors, Dr. Naina Chaudhary, Dr. Sanjay Mishra is here with us. So I'll start my presentation. So historically, when we talk about tourism and inflation, as a tourism academician, I can tell that whenever we are talking about economic impacts of tourism, why tourism is being promoted in developed countries and in fact underdeveloped countries like Uzbekistan, the government itself is so much paying very close focus on development of tourism. What is the reason behind it? Because the one reason is that this is one of the industry which can give you maximum benefits in minimum time. So this is one of the positive impact of tourism development. But on the negative side, when tourism grows, so the basic idea is that the demand for the services increase, the demand for daily products increase, and the supply remains the same. So as a result, there is inflation. The prices inflate. So this is what we are trying to find out, that is it, and particularly we are talking about only one sector, which is domestic tourism. If you talk about developing country like India, wherein a lot of focus is being paid on growing domestic tourism. Previously, before Incredible India campaign launched in India in 2002, it was only inbound tourism which India was focusing on. But now they are focusing on domestic tourism as well, because ultimately, if your natives, they travel to some other country, it is an economic leakage. Similar pattern we say here in Uzbekistan, that the government is paying close attention on growing domestic tourism, because majority of the population here, majority of the people from different regions, they do not want to travel to other regions. They want to travel abroad, be it Dubai, be it France, or any other country. So that was our main research question, which we are trying to find out, that whether it is domestic tourism is it has effect on inflation, or inflation is reducing domestic tourism. So talking about that, why we are conducting this study, because a lot of research gap we found out when we were doing this research, that very less studies focusing on this particular segment of tourism and its vis-a-vis its relationship with the inflation rate. We did not find many studies talking about this. There are a couple of studies which were touching upon these topics, but when we talk about inflation dynamics in the and its effect on the economy, we did not find any research evidence on this. And so talking about literature, as I told you before, that there is an economic impact of tourism, and that is why all countries, all across the world, they are trying to focus and develop tourism in their countries, because it can give you a lot of benefits in very less time. But at the same time, when we talk about countries like Netherlands, or when we talk about a destination like Las Vegas or Amsterdam, or for that matter, any destination where where you see a lot of tourism influx, we see that the prices normally inflate. So, but we did not find any study studying the relationship of inflation with the tourism in context to the demography of Uzbekistan. Uh, then impact of inflation on tourism. There are various studies, as I told you, various studies has been conducted where they are trying to study the relationship, but none such study we found in context to Central Asia, or particularly in terms of Uzbekistan. Uh, we we used different methodology, especially vector analysis we used for studying these relationships. As I told you, this data that we have taken from the Ministry of Uzbekistan. They have a portal wherein they have put all the data. So we have used the domestic tourism numbers starting from 2017 to 2023. And then there is year-on-year inflation rate, that how much was the inflation rate, what was it in 2014, and vis-a-vis every year, what was the inflation rate. We used time series analysis, stationary test was done, and autocorrelation analysis, co-integration test was done to find out the studies. So this was the equation that we find out, wherein the independent variable, which we are addressing as number of domestic tourists and its effect on inflation rate. Now, graphically, if you see on my left side, you see the number of domestic tourists, and you see that the number of domestic tourists, there was there was variation, but more of they were stationary. But as we see on the right side, the moment the inflation rises, the moment the inflation decreases, there is rise in the number of tourists who are coming to the country. So our research question, which was basically that whether the domestic tourism is affecting inflation, that does not we could not validate it, but certainly there is an effect of inflation vis-a-vis the domestic tourism sector. So that was the Johansson co-integration test that we conducted, and it validates our research question that inflation does affect the domestic tourism, whereas there is no effect of domestic tourism on inflation. So that was our VIR model. Anyone has any question, they can ask.
Thank you very much, Dr. Manik. I think it's a very bold attempt, because not many studies focus on domestic tourism activities. Rather, most of the studies look into the inbound students from other countries, and inbound tourists from other countries, and outbound tourism activity. And I think the strength of the study comes from the analytical framework that you have adopted, which is the vector autoregressive models, where you have looked into the co-integration of both the series. I think a fantastic attempt. Thank you very much, and all the best.
Thank you, sir.
All right. Next, I would present if Dr. Tanveer Beg and the co-authors, if they are ready with their presentation.
Yes, sir, we are ready. Share the screen.
Dr. Tanveer, am I audible?
Yes, sir, you're audible.
All right. Okay.
Yeah. Good morning. My name is Tanveer, and I'm the faculty of IT from Amity University, Tashkent. Today's topic for the conference is machine learning based wine quality prediction using Python, and it's a predictive model approach. The overview of our session is we start with the introduction, then we talk about the motivation, then we focus on the objectives of the study, then we go ahead with the review of literature, and then we consider the characteristics of wine data we have used for our study, and then we talk about the methodology, result, and followed with conclusion. Starting with the introduction, as we all know that wine has been a symbol of culture and sophistication throughout the history. And these wine qualities are checked based on the type of the grape used and the type of soil and the climate of vineyard. And further followed by the fermentation processes and aging techniques. In traditional quality assessment, we have the expert tasters and sommeliers who evaluate the wine quality depending on the characteristics like aroma, flavor, color, and texture. While in our study, we focus on using a machine learning technique for determining the quality and quantity of the wine. Okay. So the motivation of our study depends on evaluation of this wine quality by using machine learning.
Sorry to
And
interrupt,
further,
Dr. Tanvir. Your slides are not changing. Could you please make the settings? The slides are not changing.
just a minute, sir. Now, now, sir, is it visible? Is it visible now?
Yeah,
Hello.
can you scroll the slides once? Yeah, now it's fine. Thank you.
Okay, so the objective of our study was to develop a predictive model that can detect the quality of the wine using a powerful tool called Python and machine learning. And further, we have assessment through machine learning, and we use algorithm called random forest classifier and regression technique for determining the accuracy of the data which we have collected, and further to demonstrate the predictive capability of the factors which influence the wine quality. This was our objective of study. And going ahead with the review of literature, there are few literature which are published which have assessed the quality and the quantity of wine. Among these are there are something like we have regression and principal quality analysis techniques which has determined the quality of wine. And further, we also have studies based on KNN algorithm and decision trees. And to talk about our literature, to talk about our study, we are using a random forest technique for modeling, for determining the quality and quantity of quality and quantity of the wine. So the characteristics of the data set which you have considered depends on these few parameters, where we have evaluated these parameters using a machine learning. The characteristics are like fixed acidity of the wine, and then we talk about the volatility of the wine. We have determined the citric acid for the given sample, and then we also calculate the sugar content, followed by the chlorides, sulfur dioxide, and so on. These are the 12 characteristics which we have considered for our study. Based on this, we have applied a methodology using a Python, which is further used with the machine learning. So the first step which we followed was the data pre-processing technique. In this technique, we have different steps, such as your data analysis. Then we have the handling of the missing data set, then the selection of the data set and normalization of the data. Once we have completed with data pre-processing, we go ahead with the predictive modeling technique, where we use a different data set splitting technique, and then we also use a model selection and model training. Then step three was evaluation and selection, where we use different metrics such as what we have listed in the previous slide. And then we go ahead with the implementation tool using a Python libraries and reproducibility. With this methodology, we have obtained the results, which was a comparison between the support vector machine and the decision trees, which are part of machine learning algorithm. Since we have used a random forest algorithm here, which basically depends on classification regression technique. So based on that, we have obtained the accuracy, which is a parameter which are mostly used in random forest, the accuracy. And when we talk about the precision and recall, to just list out in two words, precision depends on the quality and recall depends on the quantity, right? So we were able to achieve 88% of the result, the accuracy for the given data set when we compared with support vector machine or decision trees. So this implies that the ability to generalize and accurately predict the wine quality depends on the data set which we have used. Moving further, we have also compared our results with the heat map. Heat map is nothing but it visualizes the strength of correlation between different parameters. So in our study, we have considered 1 and -1 and 3 values, such as 1, -1, and 0. If the coefficient value of 1, which we have obtained, determines that the parameter, one parameter increases, it also tends the other parameter to increase. If it is -1, it indicates that there is a negative correlation and one parameter increase, the other will decrease. When there is the coefficient is 0, then we have a linear correlation between different parameters. As we can see from the graph, we have the visualization correlation between the different parameters. This is one of the results which we have obtained. Coming to the analysis, as we have considered different parameters for our study. So these were the data set which we have obtained, and we have visualized this data using our machine learning technique. At the conclusion, since we have used different predictive analysis in our study, so the first one we have used our pre-processing, then we followed with the model evaluation, then we have a correlation with the heat map analysis, and then at the end we have used model analysis which determines the accuracy of the results, and at the end we have used transparent methodology which involves again different algorithms. Thank you, sir. Any questions?
Right. Thank you very much, Dr. Tanvir. I think a very good attempt and a very unique one, because traditionally wine testing is something which is done through the testing and senses and so on. But this is something, an advanced contribution, I suppose, and could be used in the industry uh, very positively. Any question, Dr. Danish? Okay. I think next presentation is Dr. Khyati. Dr. Khyati and co-authors, are they present here?
Uh, Good morning, sir. She is joining within 2 minutes.
Okay, she's joining in 2 minutes. All right. Maybe,
Yes.
do you have the presentation, sir? Is that possible that you
No,
can
no,
start the
sir. I
presentation?
have no presentation. Uh, Sir, she will present the presentation. I have at this time I have no presentation.
Okay, okay. So in the meanwhile, I also have one of the presentation which I'm presenting. If the co-chair, Dr. Danish, are you here? Dr. Danish?
Hello.
Yes, Dr. Danish, I think Dr. Khyati has not joined yet. So
They are having some connectivity issue. Dr. Akshay has joined. He is a supervisor, but I think we can wait for her.
yeah,
In the meantime, I request Dr.
I think
Ranish.
she's here. She
Yeah.
has just joined. She has just
I think,
joined.
but you can present. I think right now, if you're ready with your presentation.
Okay, I can present. But yes, Dr. Khyati has also joined.
But now I think you can go ahead. After you, Dr. Khyati can present.
Okay, let me share my presentation.
So I welcome Dr. Ranish and his co-authors. Ranish, you can share your screen now.
Just a minute. Are the slides visible? Yes?
Yes, it's visible, sir. You can go
Okay,
ahead.
thank you. All right, very good morning to everybody present here. Now, this particular paper, I'm co-authoring with Dr. Naina Chaudhary and Dr. Gurinder Singh and other authors. And in this study, particularly, we are looking at the impact of the rising globalization in higher education on the economic growth, particularly with respect to the developed countries and developing countries. We all know that, the pandemic has affected the not only the flow of tourists but also the flow of the students seeking education abroad, right? And student mobility per se is one of the largest component of when we talk about the globalization of higher education. Although this challenges which were faced during the pandemic period, there were alternative modes which became much more relevant, such as the massive online open courses and online exchange programs and online degrees. But given that, student mobility still holds the largest proportion when we talk about the broader perspective of globalization of higher education. So this study, we wanted to see that after pandemic, when the economies started recovering, uh, and then the student mobility regaining its momentum, what is the impact of this increase in the student mobility and also the other modes of globalization of higher education, which contributes to the economic growth of the economies, and particularly whether there is a distinction, whether there is a disparity between the growth contributions among the developed countries and the developing countries. So that was the prime motivation of the study. And if you look at the literature, there are extensive literature from authors like Professor Jane Knight and Professor Hans David, Professor Philip Albach, who are main contributors within the area of globalization and internalization of higher education. But this literature is particularly limited to contexts such as curricula, contexts such as human development, contexts such as cultural exchanges and others. So it looks more from the social perspective, from the perspective of internationalization per se, but economic perspective is somewhere missing when these authors talk in terms of globalization of higher education. But what we see here is that this process of globalization is getting more market driven, which has economic components, which has economic contributions, and that's what we take as the basic framework for our study. We look into the data from UNESCO Institute of Statistics, UIS, for 30 countries over the period of 2010 to 22, which includes the period of pandemic also, and a few years after pandemic phase as well. So we construct this data into a panel data set from the period of 2010 to 2022 for 30 countries, which is a good mix of developed and developing countries. Now, the model equation that we try to fit here is that we have to do some of the diagnostics tests before to fit in the model. And the model which was best fit was the feasible generalized least square model, FGLS, which is a cross-sectional time series model. But to come to this model, first we need to analyze the patterns in the variables of GDP growth rate that we have taken, and two indicators that we have taken, if you look at the other slide, which is the inbound mobility rate, which indicates that how many students are coming into the particular country for studying. And the outbound mobility rate also we consider that how many students are going out of the country to study. So it is the proportion of the students, given the total students, how many students are coming in to study and how many students are coming out, going out to study in other countries. And we also include a control variable, which is a dummy variable for developed countries. And this control variable will take value 1 if the observation belongs to developed country. Otherwise, it will take value 0. Now, looking at the patterns of these three variables, the dependent variable, which is GDP growth rate, and the inbound and outbound mobility rates. So all these 30 countries, if we see, majority of the countries, if you look at these drops in the GDP growth rates during the pandemic period, right? Majority of the countries have the similar drops, right? And after this drop in the growth rates, the major economies have started regaining or recovering. Okay, so that's the overall pattern that we can see in the growth rates. And if you look at the patterns in the inbound mobility and rates and the outward mobility rates, we find that during the pandemic periods, barring a few countries like this country, the inbound mobility rate has actually dropped a little bit, okay, but constantly increasing. Some of the countries shows a declining inbound mobility rate during the pandemic period, in fact, after the pandemic period also. And looking at the outbound mobility rate, we can see the similar patterns. So during the pandemic periods, the rates have gone down, but after the pandemic, particularly inbound mobility rates have gone up in case of the countries. So these are the graphs for all 30 countries that are included in our data set. Now, to fit up the model, we particularly did 3 tests. One is the test for testing cross-sectional independence, which is done to the Bush-Pagan-Allen test, and which suggests that the significant chi-square value, that there is some interconnectedness in higher education and its impact. All right. We test for heteroscedasticity also, and the probability values shows that the panels are heteroscedastic. Okay, so there is a significant difference between the economic growth across different countries. And also we test for autocorrelation, and the autocorrelation test suggests that there is no first order autocorrelation. Now, given 3 of these test results, we fit up a model, which is the feasible generalized least square model, FGLS model, and we get these coefficients. For inbound mobility, we get a positive coefficient. For outward mobility, we get a negative coefficient. Now, this coefficient indicates that a 1% increase in inbound mobility rate impacts GDP by 0.2%, okay, and positively. So inbound mobility of the students contributes positively to the GDP growth. Now, we can say that this is a very less contribution, but having said that, a 0.2% contribution in GDP is also a significant contribution. And outward mobility, we see, has a negative impact on the GDP growth rate overall for these 30 countries, which is about 0.01%, which means that a 1% outward mobility rate increases, the GDP growth decreases by approximately 0.01%. More interesting is the coefficient of the control variable, which is minus 1.5%, which can be interpreted as that the average growth rate among the developed countries, okay, or we can say among the developing countries, is about 1.5% lesser than the developed countries, which signifies that this growth contribution through the globalization of higher education is skewed towards developed countries, because developed countries tend to have more infrastructure, better institutions, and perceived quality of education. So the growth contribution towards these countries are slightly higher than the developing countries. I think I will stop my presentation here. Now, the policy implication for these, my screen has...
Slides are not moving, Dr. Anish.
Okay. Yeah.
No, it's okay.
Okay. So, in a nutshell, we can say that inbound mobility rates are increasing. The transnational higher education is playing a vital role, where we see some of the economies like some of the countries in UAE becoming large education hubs, which attracts more and more students. In fact, in Central Asia also, some of the countries have now taken a stance where they are opening up their education sectors for global institutions. So this is likely to contribute to global GDP growth rates. And the policies pertaining to the inbound mobilities and outbound mobilities further can stand. One limitation which we could see in this particular study is to include the other modes of globalization of higher education. Unfortunately, the data on institutional mobility within higher education and the mobility of the programs and the mobility of the courses, for example, through MOOCs, is not readily available, which could be included in the model to make it a better forecast. that what is the impact of the other modes of globalization of higher education and its contribution towards the GDP growth. Thank you.
Thank you, Dr. Anish. It was a very well present. You have presented very well all the facts. So now you can go ahead and call the next presenters if they are online and ready with their presentation.
All right. Okay, I think I can see Dr. Khyati over here. So Dr. Khyati, are you ready with your presentation?
Yes, sir.
Right, maybe you can share your screen and start the presentation, please.
Okay, sir.
I think Dr. Khyati, you are not audible to us.
Good morning, sir.
Okay.
Am I audible, sir?
Yes, audible now. You can start your presentation.
Yes, sir. Good morning, sir. Good morning, everyone. My name is Khyati, and I'm a research scholar in Mathematics Department, Faculty of Engineering from Tirthankar Mahavir University. The topic of my research topic is an inventory model for non-instantaneous deteriorating items under Whewell distribution and quadratic demand with trade credit policy. These are some outlines of this presentation. The first we will discuss introduction, then assumptions and notations, mathematical formulation of model, and solution procedures, sensitivity analysis, and managerial applications, and then conclusion. The first is introduction. This study focuses on the intricate dynamics of a supply chain involving non-instantaneous deteriorating items, considering a specific demand, that is quadratic demand function with respect to time, and optimizing total cost through a trade credit policy. And the mathematical model is categorized into numerical experiments, sensitivity analysis, and graphical representation to validate and illustrate the model's outcomes. To formulate the model, we need some assumptions and notations, and there are some assumptions like the demand rate is quadratic function of time, a single warehouse and a single item are considered, lead time is assumed to be 0, the deterioration rate follows the two parameter Whewell distribution, and there is no repair or replenishment of the deteriorated items during the inventory cycle. The inventory is replenished only one in each cycle, and the retailer can increase returns and produce interest, which will be followed by customer payments in purchasing cost from the retailer in anticipation of the dealer's permissible delay time being completed. And there are some notations. These are like dt is demand, theta t is deterioration, capital M representing trade credit time, and IP is interest charge, IE is interest earn, and many more. This is the mathematical formulation of the model. That is, we have developed some differential equation for various inventory levels, and there are three time periods, like 0 to T0 is that time period where there is no deterioration, and T0 to TK is the time period where the deterioration takes place, and TK to L is the time period where shortages are permitted. On solving these differential equations, we get inventory levels I1T, that is for case 1, and I2T for case 2, and I3T for case 3 with some boundary conditions. After that solving, we have developed some, we have find the ordering cost per cycle, the deterioration cost per cycle DC, and the inventory holding cost per cycle and backorder cost per cycle. And after that, we have we have find interest payable for each cases. Each cases like for case 1 is IP1, and for case 2 is IP2, and for case 3 is IP3. And IP3 will be 0 because there is no interest payable in this in that time period, TK to L. After that, similarly, we have find some interest charged, interest earned like IE1, IE2, and IE3 for each cases. Therefore, the total minimum relevant cost per unit time is denoted by TC, that is TC, TK, and for each cases we have find TC1, which is the sum of ordering cost, deterioration cost, holding cost, backorder cost, interest payable, and interest charged. For the optimality of that total cost, we have some
You're not
Khyati,
audible, Ms. Khyati.
cost like lever. Hello. Hello.
Yes, now you're audible. Please continue.
Okay, sir. We have some lemmas to check the optimality of the total cost, like when differential equation, first single differentiation of the total cost is equals to 0, at Tk is equals to Tk star. Then TC means total cost not only exists but also unique and minimum if W1 is greater than 0. And W1 is the double differentiation of the total cost with respect to time period Tk. These are the proofs for lemmas. Similarly, we have proved for case 2 and case 3 also. And after that optimization, after checking that optimization, we have some sensitivity analysis for TC1, TC2, and TC3. And these are the table of data, and representation is representation. In this graph, we can see it easily that total cost does not impact much until the parameters changes to 25%. And deviation can only be seen after 25% change in parameters, where backorder cost and parameter A, which is demand parameter, mostly affect total cost. Same for case 2. In case 2, we can see that TC2 is highly affected with A, which is demand parameter, and a slight change in demand parameter can result in rapid increase in total cost. Similar case can be seen TC3. TC3, almost all the parameters remains unchanged except A and B, like demand parameter. If we decrease parameter A and B, we can get the TC3 can be lowered. TC3 can be lowered, and from above graphs, we can say that case 2 is much affected by the parameters. It is indicating that the scenario of case 2, which is T0 to TK1, is the impact of parameter A, more pronounced variation in TC2 compared to TC1 and TC3. The observed data underscores a distinctive sensitivity of TC2 to change in parameter A, suggesting its potential significance in influencing the system's dynamics and performance. As we can say that a rise in demand parameter indicates an expansion in market demand, which in turn determines the quantity and total cost, and requires a shorter inventory cycle TK to match sales Q. That managers exercise almost contain about the demand parameter A, given its substantial impact on inventory magnitude and related expenses. And when ordering costs are elevated, inventory cycle may be prolonged, leading to greater total cost and the need for managers to place larger order. Likewise, an increase in holding cost, a more rapid turnover of inventory in order to prevent cost acceleration, which results in increased order frequency.
All right. Thank you, Ms. Khyati, for the presentation. Any questions? Dr. Danish?
No, no question from my side.
Okay. All right. Maybe you can stop sharing your screen, Ms. Khyati.
Okay, sir.
All right. I think all presentations are over for this track. On the behalf of the conference organizing committee of Amity University Singapore, and particularly for this Tashkent track, I thank you all for presenting the work. It's a great contribution towards the conference. And the authors, Dr. Sanjay Mishra, Dr. Indrajit, Dr. Manik, Ms. Khyati, Dr. Megha, Dr. Ramya. My heartfelt thanks to all of you and all the best for your future endeavors. The conference validatory would be today in the afternoon, and the certificates of the presentation will be emailed to you on the email ID that you have provided. I would request Dr. Danish just to give the concluding remark.
Thank you, Dr. Anish. So I would like to thank all the researchers for presenting their valuable work. It was indeed a very great experience for us, listening all your views. And I think we will have a great collaborations in future too. Thank you all, and see you in the validatory session in the afternoon.
Right. Thank you very much. We can leave the meeting now. Thank you.